Ladies and gentlemen, go forth, do great things. We're going over how things work, how the radio works. I'll read the whole thing, skim as you need. Electromagnetic radio waves are one of the most significant discoveries for 20th and 21st century technology. You don't see them, but countless high frequency waves are bouncing through the air around you every day. They facilitate wireless communication for things like car radios, smartphones, and Wi Fi internet. Thanks to radio, data transmissions between people is faster and more convenient than ever. Here are just a few everyday technologies that depend on radio waves: garage door openers, wireless networks, radio controlled toys, television broadcast, cell phones, GPS receivers, ham radios, police radios, wireless locks. Even things like radar and microwave ovens depend on radio waves. Communication and navigation satellites would be impossible without radio waves, as would modern aviation. An airplane depends on a dozen different radio systems. The Wi Fi networks that we depend on at work, home, and school also rely on completely radio waves from data transmission. The funny thing is that at its core, radio is incredibly simple technology. With just a couple of electronic components that cost at most $1 or two, you can build a simple radio transmitter and receivers. This article will explore technologies of radio so you can completely understand how invisible radio waves can make things possible. Contents: simplest radio, slightly more elaborate radio, radio basics, transmitters, make your own transmitting information, AM signal, FM, all that good stuff, analog digital. The simplest radio. Radio can be incredibly simple, and around the turn of the 20th century, simplicity made the experiment possible for just anyone. How simple can it get? Here's an example. Take a fresh 9-volt battery and a coin. Find the AM radio and tune it to the area of the dial where you hear static. Now hold the battery near the antenna and quickly tap the two terminals of the battery with the coin so that you can connect them together for an instant. You'll hear a crackle on the radio caused by the connection and disconnection of the coin. Your battery coin combination is a radio transmitter. It's not transmitting anything useful, just static. And it will not transmit very far, just a few inches, because it's not optimized for distance. But if you use a static to tap out Morse code, you can actually communicate over several inches with this crude device. Slightly more elaborate radio. If you want to get a little bit more elaborate, use a metal file with two pieces of wire. Connect the handle of the file to one terminal of your 9-volt battery. Connect the other piece of the wire to the other terminal and run the free end of the wire up and down the file. If you do this in the dark, you will be able to see very small 9-volt sparks running up along the tip of the wire disconnects with the file's ridges. Hold the file near the AM radio and you will hear lots of static. In the earliest days of radio, transmitters were called spark coils, and they created a continuous stream of spark as much as voltage 20,000 volts. The high voltage created big fat sparks, like you see in a spark plug, and they could transmit farther. Today, a transmitter like that is illegal because it spans the entire radio spectrum, but in the early days, it worked fine as well. It's very common because the radio waves were not heavily regulated. Radio basics, the parts. As seen in the previous section, the incredibly easy way to transmit was static. All radios today, however, use continuous sine waves to transmit the information. Very early transmitters emitted large bands of frequencies at once. All they could reproduce were simple noises which would be used to communicate with Morse code. A sine wave transmitter narrows this band down to more specific frequencies which can effectively reproduce complex information like audio streams, video, and internet data. The narrow frequency band also allows many transmitters to operate in an area without interfering with one another. We use continuously sine waves today because there are so many people with the devices that want to use a radio wave at the same time. If you had some way to see them, you would find there are literally thousands of different waves in the form of sine waves around you right now. TV broadcasts, AM, FM, police and fire radio, satellite transmission, cell phone, and GPS signals, so on. It is amazing how many uses there are for radio waves. Even with the different radio signals, it uses a different sine wave technology and frequency, and is how we are all separated. Any radio setup has two parts: transmitter and receiver. Transmitter takes on some sort of message. It could be the sound of someone's voice, pictures for a TV set, and data for a radio modem. Encodes into a sine wave and transmits it with the radio waves. The receiver receives the radio waves and decodes the message from the sine waves it receives. Both the transmitter and receiver use antennas to radiate the capture signal. Simple transmitters. The battery sends electricity to the wire becomes between its two terminals. The moving electrons create a magnetic field surrounding the wire strong enough to affect a compass. Interesting. You can get an idea how a transmitter works by starting with a battery and a piece of wire. Battery sends electricity, a stream of electrons through a wire if you connect the wire between the two terminals of the battery. The moving electrons create magnet fields surrounding the wire, and the field is strong enough to affect a compass. Let's say you take another wire and place it parallel to the battery's wire but 2 inches away from you. If you connect a very sensitive voltmeter to the wire, then this will happen. Every time you connect or disconnect the wire from the battery, you'll sense a very small voltage in current wire and change in the magnetic field, induce a electric field in a conductor. This is a basic principle behind an electrical generator. So, the battery creates electron flow to the first wire. The moving electrons create a magnet field around the wire. The magnet field stretches out the second wire. Electrons begin to flow the second wire when the magnet field is in the first wire changes. Check it out. Connecting and disconnecting the battery have a magnetic field. One important thing to notice is that electrons flow in the second wire only when you disconnect the battery. A magnetic field does not cause electrons to flow in the wire unless the magnetic field is changing. Connecting and disconnecting the battery changes the magnetic field. Connecting the battery the wire creates a magnetic field, which connects the collapse of the field. So electrons flow in the second wire as 2 moments. It's making your simple transmitter. Transmitting information. If you have a sine wave and a transmitter with a transmitting sine wave in space and antenna, you have a radio station. The only problem is that sine wave does not contain any information you need to modulate in some way and encode the information on it. There are 4 common ways to modulate sine wave: pulse width modulation, amplitude modulation, frequency modulation, digital modulation. So check it out: AM and FM. Okay, so one PWM transmitter is able to conduct the entire United States. Amplitude modulation is AM radio. AM radio stations use amplitude modulation to encode information. In AM, the amplitude of the sine wave, its peak to voltage, changes. So, for example, the sine wave produced by a person's voice is overlaid into a transmitter sine wave to vary amplitude. Frequency modulation. FM radio stations and hundreds of other wireless use FM. The advantage of FM is that it is largely immune to static. In FM, the transmitter sine waves frequency change vary slightly based off the information signal. FM uses higher frequency signals than AM, which have higher fidelity but decrease in range. Digital modulation. What is that? Digital modulation encodes a digital information onto an analog character signal and provides a higher fidelity without any other typical static. In the cases of things like wireless routers, digital modulation also allows the signal to be encrypted. This way, the transmitter will also send data to the particular devices. However, a digital signal that is too weak will become unstable. Audio data will sound scrambled, and videos will be highly pixelated. In the U.S., over-the-air has moved entirely over to digital transmission, and many terrestrial radio stations operate digital antenna in addition to the analog signals. Once you modulate a sine wave with information, you can transmit the information. Check out the sine wave as frequency. We're going to talk about that in a different video. Receiving an AEM signal. The simplest AEM receiver. Diode, wire, pipe, earphone. Antenna basics. We'll go over that later. Antenna real life examples. Analog and digital radio.